All right. So we basically have been doing separable equations for a while now, and sometimes they will give you word problems. And what you want to do is notice the words on these word problems so that you can set up the correct equations. So this is the only one you need to know for AB, which is equations that look like this, the exponential growth. Okay, the exponential growth equation. So they're going to say that this rate of growth is proportional to the original population. So when they say something like rate is proportional, proportional means you're multiplying by a constant to whatever. That means proportional. And then they're going to say proportional to the population, meaning that whatever the population was, as time goes on, it grows into something or decreases into something, but it is proportional to the population. All right, so we're going to solve this the separable equation. So first we drop that p on the other side. So that is k dt. And then we're going to integrate. So natural log p is equal to kt plus c. All right, so this is where on the homework you got to this point, and then some of you just plugged in the initial condition, some of you went one more step and then plug in the initial condition. This is in general how people will solve. They will not plug in the initial condition at this point. What they would do is raise both sides by e. Okay, raise both sides by e, and then that's going to give you p is equal to e to the kt plus c. Okay. That's going to separate into two parts, e to the kt and e to the c. Now, e to the c is really just another constant. C was a constant, e to the c is just a constant. So we're going to bring that whole thing into a big constant. So you may not want to call it c again because now it's very confusing with two c's. We're kind of running out of letters. W? Okay. Now it just looks like a word. Then that's weird. N? N, okay. So e to the c, let's say that n is e to the c. Okay, so then this is n e to the kt. Oh, that still looks like a word. That's so weird. Okay. Now in the, actually I remember. They didn't call it n. They call it P0, meaning the initial condition. I don't know if it's any better. Anyways, so this is really the exponential equation, or whenever they say something is proportional to the population, this is what's going to solve into anyways, every single time. So we're going to take that as our basis of solving and then solve some word problems. Okay, but remember when you see word problems, you can only apply them when it says it's proportional to the original population or something like that. Okay, because that's going to be that differential equation. Okay, so for example, this first one, you don't have to copy down this problem. I'm going to tell you what's important to copy down. Okay, let's read it together. The rate at which a population of fruit flies grows is assumed to be proportional to the number present. All right. Proportional to the number present immediately tells you it's dp dt equals kp. So the rate is proportional to the number present. That means the rate is proportional to the number present. Okay, that's what it means. The rate is proportional to the number present. So that means you're going to use p equals p naught e to the kt. Because if you just solved this original equation, you would have gotten here anyways. You might as well just use that result to help you solve this problem faster. Okay, so then they said, suppose there were 100 fruit flies initially, and after 3 days there are 200. You want to find an expression for time t. Okay, so that means at time 0 there were 100, and then at time 3 there were 200. Notice in this equation, there are two constants. One is P naught. Second is K. Right? E is a rational number that we have already determined the number of. T is a variable. The only thing that we don't know that's not a variable is P naught and K. Or P0 and K. So then we're going to plug in these two conditions. 0, 100. So 100 is equal to P0. Okay, so people don't call this P0. This is P naught. I don't know how to say it, but they just call it P naught. It's not peanut, but P naught. And yeah, this is how you say it. E to the K times 0.
Is that how we pronounce it, or is it how we write it?
How you say it, P naught or V naught or X naught. The 0, you don't say 0 anymore.
So it doesn't mean the initial condition?
It does mean the initial condition. So it is going to be 100. All right, that is the first condition. The second condition is 3 200. So 200 is equal to, now that we know what P naught is, it's 100 e to the K times 3. Okay, so we had to solve for K. This is basically algebra 2 again, right? So 2 is equal to e to the 3k. How do we bring that 3k down?
Ln.
Yes, natural log. And also because it's a base e, and that will cancel this base. So natural log 2 is equal to 3k. All right, I want you to solve it all the way through without using your calculator. That way, if there were a multiple choice question, you would be able to match the answer. Okay, so k is equal to natural log 2 over 3. Yes? Okay, now this is good, but that's not answering the question. The question is find an expression. So you need to actually come up with an equation. So P is equal to, P naught we said was 100. E to the, and then K was natural log 2 over 3 T. So this is the equation, and you need to be able to come up with that without putting all that in your calculator and getting a decimal, just in case. Yeah.
Can we take down the natural log?
Can you take down the natural log? Yes, you can, but you have to put that 1/3 as an exponent of 2. So, okay, so Jessica is saying, can I combine this into something else? Yes, you can. Just in case they give you something like this and then you have not seen that before. So this is really T over 3 natural log 2, right? So then if I want to cancel that, I have to put it up as an exponent, right? So this is e to the natural log 2 to the T over 3. So just a little review on the natural log stuff. That cancels. We get 2 to the T over 3. Okay, so if you forgot all this stuff, make sure you review your log stuff. So you can also say this is 100 times 2 to the T over 3. All right, so when will there be 1,000 fruit flies? That's an easy problem. So 1,000 goes in the P part, and then we have this. And we need to solve. Okay, I know you guys are in calculus, but just in case you will make this very simple mistake, please don't multiply 2 and 100 together. Okay, that's a definite no. They are base and coefficient. You cannot multiply them together. Okay, so what you need to do is divide both sides by 100. So that's 10 equals 2 to the T over 3. How do we solve that? No, try to solve this whole thing without a calculator.
Log base 2.
Okay, let's say we don't have a log base 2. We only have natural log. Natural. That's like you already told me, natural log. Okay, natural log 10 is equal to, that T over 3 comes down, natural log 2. Then what? Times everything by the reciprocal. So 3 natural log 10 over natural log 2 equals T. Okay,
that just not 3 times natural log 8?
8?
Since natural
Oh, yeah, that's another problem. Okay, this is not natural log 8. You're thinking, so we cannot subtract them. The only time we can do something like that or even similar is when you have natural log 10 minus natural log 2, you can divide. You can divide, it becomes like that. Okay? Yeah, but that's different. So please make sure you review your log rules so you don't make these kind of mistakes. Okay, that's okay. No, just every year people, we don't review it often enough, so people always forget. Okay, at this time, now use your calculator and figure out the number, but not before then, just in case you do need to do these kind of things on the test. All right, so that's it. Your homework is pretty much kind of like this. Just 4 problems, so very easy stuff.